Hello, what I'm going to do in this section is walk through some triangle similarity theorems. So basically proving that triangles are proportional to each other. So first of all, just kind of list the three that I'm going to go through, or the three that we have. So we have side, side, side similarity, which basically says that three sides of one triangle are proportional to three sides of another triangle. Then the two triangles are similar. We have side, angle, side, whereas you have two proportional pairs of sides of a triangle, and then the angle that is between those two pairs of proportional sides are congruent. We call that the included angle. And then angle-angle similarity, where if you know two angles of one triangle are congruent to two angles of another triangle, then the triangles would be proportional and therefore similar. So I'll kind of just walk through a few specifics of each of those. Starting with side, side, side. So we have these corresponding sides between two triangles are proportional. So from this diagram, side AB would correspond to side DE. So that ratio of side length would be equal to the ratio of BC to EF. And then that would be proportional to AC over DF. And if that were true, then you could say that triangle ABC would be similar to triangle DEF. So it's the fact that the side ratios would be proportional. And I'll go through an example of one of those. So if I had triangles ABC and then DEF, what I would do is first set up my ratios. And I would say, okay, I'm going to take my 12 over my 18, so that's taking AB over DE. And then I would go to the next side, which would be my 8 over my 12. And then I would go to this last side, which would be my 10 and my 15. And what we'd want to do is basically just simplify these ratios. So you have a short side, a medium side, and a long side in each of these, and those would be my corresponding sides. 12 over 18, I can simplify that as 2/3. 8 over 12 is also 2/3. And then 10 over 15, also 2/3. So because these ratios are all the same, that means that triangle ABC is similar to triangle DEF. And the order of these letters is really important. I could pick any two pair of letters, so I could pick point A and C, and that would have to correspond to DF. So does AC correspond to DF? It does. So that's why the order of the letters really does matter. What I also like about this similarity is there's no angle measurement necessary. You're only proving the triangles are similar using proportional sides. With side angle side similarity, what we're going to do is look at the ratio of AB and DE and the ratio of AC and DF. And if those are proportional, great, that's part of it, but we also need angle A to be congruent to angle D. So that is the angle that is included between those two sides, pairs of sides. If I were given these segments proportional, but I gave you B to E, or I gave you angle C is congruent to angle F, you wouldn't be able to conclude similarity. So the big emphasis here is that we have the congruent included angle, and that would allow me to say that, again, in this case, ABC is congruent to triangle DEF. So I'll just go through a quick example of that one. Same thing, between these two triangles, I have a triangle ABE on the left, and my triangle on the right is DBC. So what I'd want to do is take a look at this one on the left first, and let's just pick our shorter side, which would be the 27. And I would look at what that corresponds to from the shorter side of the one on the right, which would be the 18. And I would set that equal to the longer measurement, which is 36 from the triangle on the left, and then it'd be 24 from the one on the right. So these would be my proportional sides if these ratios are the same. So 27 and 18 are both divisible by 9. And if you divided those by 9, you would get 3 over 2. And 36 and 24 are both divisible by 12. So if I simplify that fraction, I would also get 3 over 2. So what that proves is that I have two pairs of proportional sides. And now I need the included angles to be congruent. And they are because these two angles are vertical angles. And vertical angles are congruent. And those are my included angles here too. So what I would do first is I would say that my ratio of AB over BD is equal to the ratio of BE over BC. And that first says basically this fact that's drawn here, What I would also do for some supporting evidence is say that angle ABE is congruent to angle CBD. Now what that's doing is again identifying that my included angle is congruent between those. So the last thing that I could do is make my similarity statement. So the order is huge here. If I start at point A, and let's say I call this triangle ABE, what I'm doing is going from my short side to the included angle and then back through the longest side. And I would need to do that same thing for the other triangle. So I would say it's similar to triangle, and then I would start with point D and go to the included angle. So that would be DBC. And then the order really matters. Again, assuming that I can pick any pair of letters here. If I pick BE, that would have to correspond to BC, and BE does correspond to BC, so that is true. Alright, and then the last one basically says if I have two angles that are known to be congruent, such as angle A being congruent to angle D, and angle B being congruent to angle E, then the two triangles must be similar. First of all, it's called angle-angle and not angle-angle-angle, because if two of our angles are already congruent, we can assume that the third one would be congruent because of the triangle sum theorem. So this one's a pretty easy one then, and I can still go through an example. This is the last example then. So in both these triangles, I'm given two angles. The first thing I'm given, it's the obvious one, is that angle E is congruent to angle L. However, F is not congruent to N. So what I would want to do is figure out what another one of these angle measurements are. So I could take 102 plus 30 plus the measure of angle G and set that equal to 180. So what I'm going to do is find what angle G is. This is going to end up being 132 plus the measure of angle G equals 180. Subtract 132 on both sides, and the measure of angle G is 48 degrees. So that's where the 48 would come from this triangle on the right. So I now know that angle G is congruent to angle N. Therefore, F would be congruent to M. And because I have my angle-angle similarity, I could say that triangle, and you can name this, we'll just start with, we'll go smallest to the largest. So angle FGE. So triangle FGE is similar to triangle, and then again I would go smallest to largest, MNL. And you would say that those two triangles are similar by angle-angle, and that's all you would need to support. And based off of all of these theorems that I just went through then, once you prove that the two triangles are proportional, that means that all their sides would be proportional as well. So from here I could then deduct that FG would be a proportional segment to MN, and I could pick any other two letters. I could pick GE, and that would have to correspond to NL, and I could pick ML, and that would have to correspond to FE. And then again, it goes to follow that in all these other examples as well. If you pick any angle, that angle would also have to be congruent to the corresponding angle on the other triangle. So a lot of stuff basically with these similarity theorems, and that is all.